Hey, good morning or afternoon, everybody. Appreciate y'all being on board for webinar. It's our series coming out of our attendance at National BOMA around building performance and resiliency and return on investment. We've had discussions about paving and commissioning, and today we want to dive a little bit deeper into sustainability. This call is being recorded and able for access later if you have interest, but appreciate everybody being on board. You can put your questions in the chat. We might interrupt or we might hold them to the end, just depending on the questions and the topics being discussed at the time. So my name is Greg Walterscheid. I'm within the facilities consulting practice of Terracon. And our primary presenter is Trevor Schatz, who is our National Manager of Sustainability and Resiliency. So big topic, and we're going to dive down in. Trevor's going to dive down into what that means around resilience and activities around property resiliency assessments. So real quickly, Terracon, if you're not aware, we are a national engineering consultancy. Been around, we're in our 60th year, focused on the life cycle of a building from initial site selection and geotechnical and environmental consulting through materials testing and facilities building related performance consulting to basically take our clients all the way through their conceptual design into actual construction and then operation of their buildings. As you can see by the numbers, we work all over the country, a great number of offices, so we are local to your business and to your buildings. And we're very much focused on safety and pride ourselves on our nearly 8,000, probably today 8,000 employees working safely and going home safely every day. And as part of that, we like to kick off with a safety moment. So everybody, I think, at least 49 of the states went into daylight savings time. And so we see that as a challenge, right? And for our folks to change their schedules, and our schedules are modified by that time change, whether it's a interruption of sleep patterns and rest, driving, you're now driving into sunlight or into darkness, depending on your routine. And so you have to change how you think about what you're doing. What you were doing a week ago is different now because of the time change. And then animals, right? It's active time, that fall of the year, where a lot of places have a lot more animals are active. And you can see that by the roads and activities around those with animals, and especially deer, that can cause some big challenges for vehicles. So with that, I will turn it over to Trevor to jump in and talk about the topic of the day. And again, if you have questions, please post this in the chat and we'll be monitoring that as we go forward. So Trevor, all yours.
All right, thank you, Greg. Thank you all for attending today for his presentation on property resilience assessments. So a little bit about Terracon and the group that I work within Terracon. We are the Sustainability and Resiliency Services Group. We are a distributed service, which means that we work with all different practice groups and service lines to accomplish sustainability and resiliency goals. Within our group, we have 3 different pillars. We have sustainability and climate solutions. So within that group, we work predominantly on materiality assessments, primarily for environmental social governance, ESG programs and development. We also do product lifecycle assessments within that group. We do development and refinement of ESG programs, implementation of EHS compliance, and sustainability ESG management software solutions. We do work on different ESG types of questionnaires, such as CDP, EcoVadis, GRI, GHG protocol, and SASB as well. So look to us for your ESG needs. Healthy and sustainable infrastructure. So within this group, we look closely at sustainability certifications such as LEED, WELL, Envision, and CITES. We also work closely with our geo team on low carbon concrete consulting. We do complete life cycle analysis and embodied carbon analysis in-house. And we also generate environmental and health product declarations, EPDs, as well. We do carry forth property and facility condition assessments. And also we have a testing group that does indoor air quality testing for air, hygiene, and mold as well. And then our last group here, resiliency, planning, disaster response, and recovery. This group focuses primarily on what I'm going to present today, property resilience assessments. In addition to that, we work on disaster preparedness and planning, grant writing for different post-event assessments for disaster restoration, ecosystem design, development, and operations. We have a landscape group that does wetlands mitigation, and we do site assessment surveys. So that's a little snippet of our services within our group here. So at Terracon as well, we have a sustainability report, which is a really great way to understand who we are and what we do. We have a strategic framework that has 3 different positive impacts that we focus on. Our company, so we try to be a responsible, sustainable, and resilient business. Our work, delivering projects sustainably and offering S&R services to support our clients' goals, and our giving as well, extending impacts beyond our core business activities through Terracon Foundation and employee-led efforts. So the sustainability report can be a great way to understand who Terracon is and also benchmark Terracon against other companies through their sustainability reports as well. So please reach out with any questions on that. So property resilient assessments. So let's talk a little bit about what that is, right? A property resilient assessment evaluates a building or infrastructure's ability to withstand and recover from natural hazards and climate-related risks. It follows the ASTM standard, which we're going to discuss today, and it outlines essentially a 3-stage process. All right, stage 1, hazard identification, stage 2, risk evaluation, and stage 3, resilience strategy development. So we're gonna dive more into that as we proceed here. Okay, a little bit about ASTM before we get started, right? It's a consensus-based standard-making organization. It relies on volunteer experts to come together and develop agreed-upon approaches to solve industry issues. ASTM does provide a balanced process that is impartial and inclusive and provides an opportunity for end users of the standard to collaborate with professionals providing the work product. We have seen ASTM throughout the market. I'm sure you've all seen it extensively. And knowing about the inner workings of it is important in the context of this presentation. So again, there's a direct and equal participation in ASTM for all persons and organizations. And, ASTM strives to make the international standards transparent and readily available online. So a third-party transparent organization, right? In addition to that, the way that ASTM standards are voted in, the producer votes are equal to those of users. It's impartial, inclusive. It attempts to be fair to all, and it has an appeal process to avoid protections and avoid abuses. ASTM, it strives to constantly respond to market needs. So keeping pace with industry and innovation is a big part of ASTM. And then, remaining relevant to the global marketplace, through performance-based applications. In addition to that, ASTM does fund science and technical quality and research projects that specifically address risks and needs in the marketplace and associated with ASTM standards. ASTM also collaborates with other standards organizations partially to avoid duplication and to pursue international standards work in a smart way. So we're proud to work with ASTM. That they are a third-party balanced organization that can reflect the kind of our qualities in the marketplace. So, you're likely familiar with other standards that you see, throughout the market, right? ASTM 1527, directly deals with phase 1 assessments, ESA standards for phase 1 assessments of properties. ASTM 2018 Standard Guide for Property Condition Assessments. These, both of these standards are very closely aligned with property resilience assessments. And so we look to these types of other ASTM standards to inform this, the new standard that we are developing right now, which is PRAs. So this, the strength of ESTM standard is that the federal government, prefers to work with consensus-based standards making organizations, right? And as when possible, such as in the case of phase 1 ESAs, the EPA has an all-appropriate inquiry rule, right? And what that means is that it establishes a federal use and development of voluntary consensus standards and conformity of assessment activities, which means that the federal government utilizes a lot of the ASTM standards and products for their buildings and for their methodologies moving forward. So an important, arbiter of that is what we call an OMB Circular A119, establishes policies on federal use and development of voluntary consensus standards. And so it establishes the standards and the products that are going to be used on federal and DoD projects. And so as a result of that, we've seen kind of a new standard develop. It's called the Enhancement and Standardization of Climate-Related Disclosures for Investors, right? This was developed for the Securities and Exchange Commission, and the SEC adopted these amendments to its rules under the Securities Act, right? And what that will require essentially is that registrants need to provide certain climate-related information in their registration statements and annual reports. This means that anybody who is a publicly traded company that registers with the SEC is required to provide climate-related information in their statements, right? And the final rules require that information about a registrant's climate-related risks that have materially impacted or are reasonably likely to have a material impact on its business strategy, results of operations, or financial condition have to be reported. So in addition to that, under the final rules, certain disclosures related to severe weather events and other natural conditions will be required in a registrant's audited financial statements. So this is an important concept to understand because the federal government has been the early adopters for property resilience assessments. It's been integrated into the UFC, United Facilities Criteria program. This is a program that provides planning, design, construction, sustainment, restoration, modernization criteria for Department of Defense facilities. And it also underpins the sustainable methodologies that they utilize as well. Now, as we all know, the SEC requirements were suspended in the current administration, but many other organizations, including some elements of the federal government, are continuing to follow those strategies of reporting the climate risk strategies. So this is very important to understand in the context of property resilience assessments. So let's talk a little bit about what underpins, right, property resilience assessments. Climate risk drivers, right? We see these in commercial real estate, and they usually emerge in two different ways. Physical risks, which represents like extreme weather events causing property damage and operational disruptions. And number two, transition risks. These involve evolving regulations, shifting market values, and the financial pressure of higher insurance costs. So these are two components that play a large role in decision making in primarily the commercial real estate world, right? Think of it this way: physical risks are direct impacts from climate events, while transition risks stem from shift to like a lower carbon economy and decisions around advancing technology that we have, right? So we are looking to challenges in addressing the risk, right? We have data and complexity challenges, right? Managing and integrating climate-related data is complex. It really is, and it requires collaboration among different stakeholders to ensure accuracy, right? And then in addition to that, if you've worked in this field, you've seen this many times, we have short-term focus, right? Some industry stakeholders, they prioritize short-term interests over long-term climate adaptation. They view climate change sometimes as a less immediate threat. So, an example of that may be, a developer of condominiums who's looking to just develop and sell immediately versus, say, a university campus in which they are going to be owning and managing that entity for a long period of time. So those examples, those differences will arbitrate how the climate-related risks are reported and incorporated into the project itself, right? So there's a lot of different components associated with, addressing climate risk drivers, right? Large organizations use investor relations to try to communicate to their shareholders and to the marketplace their efforts towards, climate risk strategy assessments, right? Of course, um, the board of directors of any organization understand how to preserve and protect value, right? And climate risk assessments are a great way to enhance and deepen the understanding of the value of a project, right? Insurance companies, risk management is a huge part of that, of any climate risk strategy. So that's a massive driver there, right? And then exit strategies, as we mentioned, a developer who is building a spec project and wants to flip it is going to want to understand exit strategies, and climate-related risks associated with that are going to affect the end valuation of their project. Also, rising cost of insurance. We all experience that on a daily basis. That is a big driver for us to understand climate risks. And then regulatory pressures. As we just discussed in the previous slide, the government is moving towards requiring climate risk reporting. And in Europe, that is already required in many different cases. So climate risk drivers are a big factor in property resilience assessments. So let's talk a little bit about the PRA standard for a minute. It began in April 2021, primarily driven by the growing pressure for climate risk disclosures, the increasing prevalence of climate risk vendors, also and an interest on the part of owners and investors to enhance their existing risk management process, right? And so we've seen that there is a need in the marketplace for enhanced climate risk analyses. And who exactly is asking for this, right? One might ask, right? So as I mentioned in the previous slide, let's understand the marketplace a little more clearly in relation to property risk assessments. Insurance underwriters have been using a version of PRAs for many years already. They use it to assess risk and adjust premiums. Okay, appraisers of properties too. They've been, they are going to utilize this to factor resilience into property valuations. Utilities and power transmission, right? They use it to protect critical infrastructure. Here in California, we have continuous problems with wildfires due to, utilities and power transmission failures. And so that's a big way of trying to prevent wildfires. Healthcare facilities, right? They look closely to ensure continue quality of care in their facilities. Asset managers, right? They need to ascertain risks to understand the real estate portfolio for their capital planning cycles. And developers and investors, as we mentioned before, for their ESG, environmental social governance compliance reports, their risk mitigation supports, the reports to their investors, to their stakeholders, very important. NEPA and environmental due diligence consultants, right? They use PRAs as well to support regulatory reviews, making sure the reports are aligned with current regulatory oversight. And of course, municipalities, right? Local and statewide, federal municipalities, they need it to ascertain climate risks to their real estate portfolios, and they use it essentially for budgeting and bonding too. It arbitrates, how we approach our collective resources. And so moving forward here, sorry, we're having a little bit of slow day with Teams. Bear with me for one moment. We're going to have to reboot. Apologies. Okay, thank you for your patience. We have all experienced the Teams glitch, so please give me a moment to resolve this. Sorry, we're going to have to go back and reload Teams. We've all been there before, I'm sure.
Yes. Sorry, Trevor. You know, the thing I noticed about the PRA is that it is the sectors or the industries or the types of owners that are involved. It's really widespread that everybody should have an interest in the PRA side of things and what it means for their buildings, whether like to those factors that you mentioned. There's so many factors and variables that a lot of folks are going to need this service. And like you said, governments are headed that direction to try and require it so they have this base information, regardless of what the angle of your interest is, right? So whether it is just climate or whether it's performance or insurance or operational consistency, whatever it might be, right? So.
All right, looks like we're back online here. Thank you, Greg, for stepping in for a moment. Okay, so moving on to our next slide here, types of physical risk. Right, before we dig into the PRA standard itself, let me anchor first us regarding what the PRA covers. Keep in mind, the PRA is solely focused on physical risk, right? We're looking at climate risk for buildings, right? Primarily in sites, right? We're looking at wildfires, sea level rise, all these physical risks, heat stress and water stress. And keep in mind, climate risk for buildings are categorized, as I mentioned before, as physical, right? Damage from events like flood, fires, and high winds, and then transition, such as financial and regulatory impacts, right, from carbon emissions regulation. So physical risk can be acute, right? Sudden, like hurricanes, or chronic as well, like gradual changes like sea level rise. But both can lead to direct financial costs, operational disruptions, and damage to structures, including foundations, roofs, and windows, right? So, breaking down our physical risks, our acute and chronic physical risks, right? We see a lot, risking like flooding, right? That can compromise a building foundation, cause water damage, right? Of course, high winds, right? Those are going to damage roofs, windows, and doors. Wildfires, right? Those obviously pose a direct threat to structures, especially in susceptible areas where fire services cannot reach them in time. Heat waves, right? They can damage materials. They lead to increased energy demand for cooling. Sometimes mechanical systems are not correctly designed for those high heating loads. Also, as we know, chronic risks, right? We see gradual changes from long-term climate shifts, right? We're seeing that in different areas of the world right now. Sea level rise, right? In our coastal areas, they're seeing increased risks of flooding and erosion from coastal properties, right? Of course, rising temperatures as well. It leads to soil shrinkage, which damages foundations and increase the likelihood of wildfires. Increased precipitation, right? Wetter winters leads to damp and mold issues in buildings. And drought too. That can cause soil to shrink, subside, affecting foundations, particularly in clay-heavy soil areas. And increased pests as a result of that as well. Warmer summers can increase pest activity, which may damage building structures as well. Okay, so those are the physical risks, right? So our transition risks, right? Regulatory changes, new building codes affect all buildings, performance standards, and energy efficiency requirements. They require, a cost upgrades, right? Those initial costs are going to go up for those builders, and that can be a challenge. Market shifts, right? We see sometimes a lack of adaptation that can devalue properties and increase insurance premiums. And then litigation, right? Always a looming threat. Buildings that are not resilient leave themselves open to face legal action following climate risk related damage. And then finally, carbon pricing, right? A cost on greenhouse gas emissions can possibly increase operational costs for buildings, right? And so those are kind of our two lenses that we're looking through with our PRA evaluation, physical and transition risks. Okay, physical risks to buildings, right? You can see how it's interconnected with a number of other elements, right, within the commercial real estate space, right, and in the built environment overall. So we see underwriting, playing a large role in this, due diligence and processes, sustainability reporting obligations, community resilience, So our existing due diligence processes, right, that we have, including ESAs and PCAs, seismic appraisals, those all play a part in property risk assessments, right? And so it's important for us to understand, the interconnection of these different services and how they can support each other, how we can bundle them together for our clients. And so it's crucial, to understand is to protect assets, to try to ensure business continuity. Overall, what we're talking about is, trying to adapt to a changing climate. And so, understanding physical risk and resilience is a large part of this discussion here. So let's talk a little bit about our PRA task group, right? It's WK62996, right? It's an ASTM International Task Group responsible for developing what we call the Standard Guide for Property Resilience Assessments of Buildings. So that guide has been published and is accessible for free on the ASTM website, right? It's been published under, if you want to look it up, it's ASTM E3429-24. That can help you find it a little bit easier. And we'll be sending out this presentation and notes as well, so you'll have this if you need it. So this guide, the ASTM guide, provides a standardized framework and best practices for evaluating physical climate risks and vulnerabilities of buildings, and as well as identifying their measures to enhance their resilience, right? So it's important to remember the PRA guideline is not intended to compete with other existing standards. In the last slide, right? It's designed to instead capture and reference the other standards in an ASTM accepted format, ultimately, right? And so, the ASTM PRA standard is not yet mandated, but it is increasingly used in due diligence, as we discussed, in underwriting as well, capital planning, and particularly regarding market cohorts, as we discussed before. So we see this emerging, right? We see it like this as an umbrella guide, right? Outlining processes for multi-hazard evaluations of resilience, right? We also see PRAs as a foundation from which, hazard-specific practices can be created, right? We acknowledge that this is maybe the first iteration of PRAs, obviously not the last iteration to come, but the growing standard, right, that needs to align with other existing standards and frameworks. So that's the vision of the PRA task group right now. And just so you all are aware, I'm on the property resilience task group. You can be too. If you're interested, feel free to reach out to myself, and I can help you with that. So the PRA process, right? What is the PRA process really composed of? As I mentioned before, property resilience assessments are designed to evaluate a building or infrastructure's ability to withstand and recover from natural hazards, right? Like floods, wildfires, earthquakes, and climate-related risks, right? So just to underpin that again a little bit before we go into the process, right? So again, the PRA assessment is a three-stage process, right? Stage one, we're going to identify the hazards that may pose a threat to the property, right? This is often done as a desktop screening analysis, right? We review models and we map outputs, and then we note hazard verification within the region itself, very region specific in that stage, right? So stage two consists of a site inspection. So we're going to send a person out physically to inspect the site. They will evaluate the vulnerability of the building to the hazards identified in stage one. So stage one will be used as a guide for the in-person evaluation of the asset, and when we go in person to inspect it in stage two. Okay. In stage two, right, we're going to generate what we call a value at risk number. This is just a way to say that we might have a number of 0 to 10 or a 0 to 100 number that tries to identify the level and standard of risk that the asset may be experiencing, right? And then in stage three, right, this is where we're going to identify what resilience measures could be employed to reduce the vulnerability of the building, right? So we're going to actually discuss if the building has, say, it has flooding issues, if we need flood barriers, right? If the building experiences high wind challenges, we might be looking at the glazing and the roofing, right? A number of different components here. So in the stage 3, our output includes a rough order of magnitude cost of implementation, along with comparison to a reduced value at risk. Okay, so I'm gonna go into that a little bit further, but just so we all understand that our overall, procedure here is interdependent, meaning that stage 2 relies on stage 1 and stage 3 relies on stage 2 and stage 1. So we build these together and try to, in our discussions with the client, we are developing an understanding of what that value at risk component is. So in order for us to be speaking the same language, right, it is very helpful to have, say, a key, a color-coded key, right, of severity of risk, or a scale of 0 to 10, or a scale of 0 to 100. This makes it much easier to have a conversation with a client that may have no background in these topics, to impart an extra layer of understanding. So let's dive into the process, right, in some detail here. Here you see the same process, right, as I mentioned before, but we're with a little more detail here. As you can see, we've listed the physical hazards to the left here, the natural hazards, right, the climate change hazards, as we discussed previously, right? And one of the most important parts of the PRA is before the assessment begins, right, we're going to work with the user to understand which hazards, which timeline, and what the risk of the user, right? Or the owner, we could call them, right? So we want to be addressing the PRA in a strategic way that helps the user their goals, right? Understand and map their goals, help the user attain their goals in a very specific way, right? So in stage 1, let's dive into this a little more deeply, right? In stage 1, we're going to look at screening and identifying hazards, right? So I mentioned before, we're going to review, model, and mapping outputs, right? So what is a model and mapping outputs, right? So what these really are regional hazard data, right? These can come from many different sources, right? They can come from National Oceanographic Administration, NOAA, right? The World Bank also has a map that describes relative climate risk hazards globally as well. And then we also have commercial risk modeling and mapping sources. So in this first stage here, the stage 1 screening of the hazards, we are looking at publicly accessible data that could include flood maps as well. We're looking at publicly accessible data, and we're aggregating that data in a desktop analysis, okay? Moving on, so stage 1A, right? This is the hazard verification, hazard confirmation stage. So in this site-specific desktop review of the local or regional natural hazard, we're going to have risk plans and maps, right? We're going to include those in the report to the client, right? This is going to be the hazard report. So these are the criteria that comprise that first desktop report, right? The regional hazard data, right? The public and commercial risk modeling and mapping information, right? And then we're going to combine that with our local and regional natural hazard and risk plans, right? That's going to comprise the desktop review predominantly, okay? Moving forward, risk and resilience assessment, right? That's our stage 2 component. Risk and resilience assessment, right? Our site-specific risk and resilience assessment, okay? This is when we're going to use the site inspection tool, right? We're going to go on site and we're going to review the building characteristics. Although important to understand, of course, before we even go to the site, we're going to want to understand a lot of things about the building. We're going to want to do our due diligence, reach out to the owner, the facilities team to get all the information we can about the building. This is going to include criteria such as the age of the building, the occupancy, right, the construction type of the building. It's very important, obviously, for us to understand the typology of the building, right? An airport facility is going to be much different than an acute healthcare facility or a manufacturing facility. Those are all going to have different characteristics associated with them that are going to dictate the type of inspection we're going to do and the type of report that we're going to generate as well, and recommendations, right? So we're going to review the building characteristics to essentially assess the vulnerability to the hazard. Again, hazards we already identified in stage one, right? So we're going to stick with the hazards that we found, the physical hazards, maybe the transitional hazards that we found in stage one, and then we're going to carry those into stage two, and we're going to dive more deeply into those, right? We're going to make them more applicable to the building, the asset itself, right? And throughout this process, the stage two process, we're gonna maintain a focus on safety, right? We're gonna want to understand, assess the safety of the building, the current safety protocols they have in place, policies they have in place, the damage to the building. Maybe we've been called in after a natural disaster, and we're assessing the damage to the asset as well. And in the same context, perhaps we've been asked to look at the functional recovery time, right? What's the owners coming to us and saying, can you assess the damage to my building? How long is it going to take before we can be up and running again and have the building occupied again? And so there's a very important part of the PRAs is understanding, how safety and recovery time plays a part in that. And in addition to that, right, what are the material impacts related to the community, right? As we all know, like no building or asset or site exists in a vacuum. It's connected to the wider community in many different ways and shapes and forms, right? Through public access, through safety, through maybe transportation lines, networking hubs that are connected, right, to public impacts. So we want to understand and communicate with our partners within the local municipality, right? And so that might, affect in natural disasters. Again, this may, the material impacts may affect community resilience lifelines, right? If we are talking about a acute healthcare facility or an airport, we're going to want to work closely with our municipality, okay? So that's stage two, right? So again, stage two, site-specific risk and resilience assessments, right? We're looking at the site-specific vulnerabilities. And then, right, we're going to move on to stage three now, customized resiliency measures, right? And so within this context, we're identifying specific resilience measures, and we're providing cost estimates, if possible, not always possible. So let me give you some examples here. We have a flood barrier installation that needs to be installed, right? We're relocating critical equipment that maybe was damaged by floods. We have energy efficiency and power redundancy issues, maybe with backup generators, things of that nature. We have hurricane rated glass and roofing issues, right? Maybe the glazing needs to be replaced because it's not hurricane rated. Same thing with the roofing, right? Perhaps it's not rated for high wind events as well, right? And so a big part of stage three is we are actually planning out the methods needed to ameliorate the issues that the asset is experiencing, right? And so as part of this, we're going to recommend full community resiliency study or advanced engineering/design consultancy if needed. So we are going to be partnering with other disciplines within this stage, right? We're going to bring in, maybe stormwater runoff specialists, some structural engineers, right? We're going to want to bring some commissioning folks, right, to look at all the equipment, right? Some building enclosure specialists to look at our moisture intrusion and our glazing, right? If that's all in good condition. So we have many different interconnections within stage three to other practices and other disciplines and other expertise as well. So depending on their purposes and needs, right? It's important to understand, like many of the users, they can stop at stage one, right? Stop at stage two, or utilize an iterative process based on the results of each level, right? So moving on. So to show you in depth, right, what does our hazard screening identification look like here, right? This is what it looks like, right? A hazard screening, again, is for property risk assessment, right? Again, it involves identifying potential hazards through a multi-step process that includes reviewing data, right? The data we're looking at, performing physical inspections, and consulting with experts to assess risks. So just reiterating what we just discussed before. So how are we going to do this? We're going to do this by identifying our first potential hazards, right? Our natural hazards, our hazardous materials, our structural issues, right? And then we're going to evaluate the associated risks, right? What does that mean? The probability and the severity of that risk. And then we're going to determine the control measures to mitigate them, right? So what we're looking at here right now is a hazard rating chart, and below it, a flood hazard area map. So this can give you a clear understanding of what that desktop screening analysis is going to be comprised of to a certain degree. So you may wonder, where is this data coming from, right? So again, as I mentioned before, we're using NOAA, National Oceanographic Administration, climate data records, and organizations like Moody's, even, they have some databases of information like this as well, right? So again, this is hazard screening identification, step one, right? We're consulting multiple data sources. We're also using FEMA flood maps. And then we're also looking for more comprehensive data that includes what current and future risks from sources like Fathom maps for flooding, as well as local hazard and climate change reports. So we're trying to aggregate a lot of data within this first hazard screening identification step here. Step two, a property level risk and resilience evaluation, right? So again, our site inspection and review of building characteristics, right? We're assessing the vulnerability, right, within the context of the hazards identified in stage one, right? And we're assessing safety, damage, and recovery time, along with material impacts related to community resiliency lifelines, right? So we're evaluating the risks, right? This includes, looking at the potential harm from identified hazards, including potential safety concerns and structural vulnerabilities, right? We're going to assess functionality, right? This involves evaluating the property's ability to withstand impacts and also the time it would take for it to recover functionally after an event, right? And then we're going to use qualitative and quantitative methods to understand this, right? So the risks can be expressed in many ways. For instance, we can express them in qualitative terms like high, medium, or low, or through quantitative data like potential monetary damage. So different ways we can communicate to the client about what we're experiencing here, right? So moving on to stage three, right? These are our real resiliency measures designed to identify solutions, right? So this final stage, right, we're going to identify specific actionable resiliency measures, and we're going to try to improve the property's performance and recovery capabilities through these measures, right? So first, we're going to identify specific resiliency measures, and then we're going to move into providing cost estimates and looking closely at the types of methods that are prioritized to ameliorate the issues that the asset is experiencing, right? As we discussed before, we have numerous examples such as flood barriers, power redundancy issues, hurricane-related glass as well, and so moving through this, right, we can understand clearly, right, protection strategies, right? We need to reduce a building's vulnerability to extreme weather, right? So we're going to evaluate, the perimeter flood proofing. We're going to look at things like resilient elevators, right? Here in California, where I am, we have serious seismic issues, and resilient elevators are a big portion of dealing with an earthquake event and how that may affect that piece of equipment in the building. Of course, backwater valves and sump pumps are really important for buildings that are subsurface. Huge flood events can create serious issues with backwater valves, right? Adaptation and strategies that improve a facility's ability to adapt to changing climate conditions, right? So we're not just looking at the immediate impacts of these climate-related physical impacts. We're looking at, right, the ability of the facility to adapt to these climate conditions, right? So we're gonna look at the envelope efficiency, right? We're going to do commissioning of, building envelope commissioning. We're going to look for moisture intrusion. We're going to test the glazing for, see what kind of condition that is in, right? We're going to make sure our equipment is elevated and our living spaces are elevated, right? Because any type of backup generators we have in a flooding event could immediately be knocked out if there's in water. Subsurface stormwater management. Some of these evaluations could include subsurface evaluation of utilities, right? Are drains in good condition? Are they operating as intended? Right. And as I mentioned before, the window shading and distributed heating and cooling, right? We may want to increase our glazing values, right? Our solar heat gain coefficients and our U values, right? To resist the increased amount of heat that your building may be experiencing year over year, because that is going to put have a direct impact to your mechanical systems, right? Backup strategies that provide critical needs for when a facility loses power, other services. So we work with a lot of acute healthcare facilities. They cannot be without power, right? We have life-saving measures within them, airports as well. We need to make sure that our backup power and our critical systems are in working condition and are elevated from flood or protected from wind dangers as well, right? Same thing goes for emergency lighting, making sure that our analysis is comprehensive and includes, access to potable water as well. A school system that's on lockdown, the children can't leave, are going to need access to potable water for the time period that they're stuck there. So, our stage 3 is really quite a comprehensive evaluation of a building's ability to withstand use natural hazards, but also adapt to them in certain fundamental ways, right? So very important factor. So I want to give you a couple examples to make this more relevant to you and your understanding of property resilience assessments. So hurricanes Helene and Milton caused more than $100 billion in combined losses in the US. Most of it was uninsured. So these storms led to hundreds of fatalities and left millions without power and water for weeks. So after that, commercial buildings in climate risk zones did start to use property risk assessments, right? They used it for climate modeling to strengthen their structures with elevated designs. They used it to replace glazing and roofing, and also used it to protect essential systems through elevation and waterproofing, as we just discussed. So we see, these case studies being utilized extensively for different applications, right? Another one, right? Phoenix heat mitigation strategy. So Phoenix, as we all know, faces an elevated risk from climate change due to longer and more frequent heat days. So this strains infrastructure and impacts public health. Right now, projections are showing Phoenix could experience around 47 days a year with temperatures over 110 degrees by 2050. So this has prompted mitigation and adaptive changes such as building code changes. So new building codes are being implemented to make structures more heat resistant and efficient, requiring measures such as increasing the size of cooling systems, as we discussed, using low albedo cool roof coatings. This keeps the building cooler and reduces urban heat island effect. Updating heat and UV resistant glazing, as we discussed, substandard glazing is going to make the building warmer and put an undue load onto your cooling systems, your mechanical systems. The city also stepped forward to develop something called cool corridors. These are used in vulnerable areas with high pedestrian activity, and it helps provide shading and cooling. Also, the city's developed a heat response plan. It's been expanded to include October, right? Because the climate-related heat index is expanding year over year. And, again, this is due to an unprecedented late season heat wave in 2024. So as we can see, right, there are some immediate property resilience assessment case studies that we can learn from moving forward here. So I want to thank everyone for listening to this presentation and participating. I am going to open up for questions now. Looking forward to having a nice, lively conversation with you all.
Very good. Thanks, Trevor. See folks on, if any questions or follow-ups, one of the, where do you see Trevor, where do you see the most activity right now who's doing, which sectors are doing PRAs? I'll call it consistently, uh, commercial side, healthcare. You mentioned government. What are you seeing there?
Yeah, thank you, Greg. Um, we are seeing PRAs being used primarily in two areas. We're seeing, as I mentioned before, the federal government has adopted certain elements of PRAs as mandatory for renovations and new constructions. And this includes DOE and armed forces as well. In addition to that, we are seeing it utilized quite a lot in the insurance space. So insurance underwriters, appraisers, we see them utilizing it for their valuations. So those are the two major areas that we are seeing in the market right now. That is not to say that PRAs are not being utilized in other areas. We are seeing it right in disaster response and recovery programs for municipalities, how they're using it. And of course, we're hoping to see it, spread to the SEC requirements. We're hoping those will come back online as well. If that does take place, we're going to likely see PRAs be much more widespread than now. So we are trying to pre-position ourselves for that anticipated growth.
So one more question, maybe if ASTM comes in and adopts an official standard, what will the things be added to it, or will pretty much stay as you described it today?
Great question, Greg. So, as I mentioned in the presentation, the PRA guidelines are designed to work with other ASTM standards, for ASHRAE walkthroughs, for our ESAs, right, for PCAs as well. And so, one of the likely sort of adaptations to PRA will be the incorporation of some of the other criteria within the other ASHRAE level standards so that they can be effectively bundled together moving forward. That is one of the potential changes that we are seeing in PRAs as implementation grows, as adoption increases, the bundling of these services so that practitioners that already understand how to do ECAs and PCAs can also add PRAs to their evaluation list as well. So we're hoping that will make a really positive impact in the marketplace overall.
Right, because it sounds like a lot of these things are being done by different folks and from different angles. So bringing that all together should provide some. This won't be a new service; it'll be just that maybe differently bundled, right?
Right, and that really we're hoping should increase the rate of adoption because it's not essentially such a new service than the pre-existing PCAs or BCAs that an owner is doing. And a PRA only gives them more redundancy, more protection, to be able to communicate to their users, their shareholders, to their insurers that they're covering, even wider footprint, a risk footprint, essentially.
Absolutely. Well, if no other questions, we'll call this everybody educated. And Trevor, thanks, and look forward to the next one from Terracon.
Thank you so much, Greg.